Hello and welcome to yet another lecture on Basic Electrical Engineering, paper code ESEE 101. Myself Prathita Roy, Assistant Professor of Dr. Sudhir Chandra Institute of Technology and Sports Complex, Department of Electrical Engineering. Today, my topic is auto transformer and three-phase transformer connections. Lesson objective: after the end of this topic, student will able to understand the concept of auto transformer and three-phase transformer connections. So auto transformer. An auto transformer, an electrical transformer only with only one winding. The auto refers to the single coil acting on itself and not to any kind of automatic mechanism. This is a pictorial view of an auto transformer. So, an auto transformer is a single winding transformer. It's a single winding transformer that is clearly seen from that figure. It's a single winding transformer in which a part of the winding is common for both the high voltage and the low voltage side. A part of that winding is common for both high voltage and low voltage side. So auto transformer is an electrical transformer with only one winding, where the auto refers to the single coil acting on itself and not to any kind of automatic mechanism. And in other words, we can say that auto transformer is a single winding transformer. It is clearly shown in this figure. It's a single winding transformer where a part is common. This part is common for both high voltage and low voltage side. This is known as auto transformer. So this is an auto transformer where N1 is the primary trans, that is lies between the section 1 to 3. This is 1 and 3. The total number of trans is known as the primary trans N1. N2 is the secondary trans that is lie between the section 2, 3. This is called the N2. The secondary trans that is lie between the section 2, 3. I1, that is the primary current, and I2 is the secondary current. If I do the KCL at that particular point, it is I1 plus I2 minus I1, that is the I2 that is flowing to the secondary side. V1 is the primary voltage and V2 is the secondary voltage. This is the entire primary side and this portion is the secondary side. So from that figure we will get that, so this portion, the number of turns in this portion 1 and 2 will be total in number of turns, that is N1 minus N2, and the voltage is in this side is V1 minus V2. So from that particular figure we will come to a mathematical approach. If I do that, so V2, that one, and V1 minus V2. So in this part, the total number of turns is N2 divided by N1 minus N2. So it is V2 N1 minus N2 equal to N2 V1 minus V2. So V2 N1 minus V2 N2 equal to N2 V1 minus N2 V2. So V2 N1 equal to N2 V1. So V2 by V1 equal to N2 by N1 equal to K. So in this way, we can design the mathematical expression of a auto transformer, that is known as theory of auto transformer. So V2 by V1 equal to I1 by I2. So V1 I1 equal to V2 I2, that is input equal to output. So the output of an auto transformer can be derived that the primary and the secondary windings of an auto transformer are connected mechanically as well as electrically. So the power transferred primary to secondary inductively as well as conductively. So the output apparent power is V2 I2. So apparent power that is transferred inductively is V2 I2 minus I1. So that is V2 into I2 minus, from that I1 we can write it is K I2. So V2 I2 1 minus K, that is V1 I1 1 minus K. So the power that is transferred inductively is equal to input into 1 minus K. Power transferred conductively is input minus input into 1 minus K. So that is K into input. That is the power transfer inductively is input into 1 minus K, and power transfer conductively is K into input. That is the power that is transferred. So copper savings in an auto transformer. So the same output and the voltage transformation ratio, an auto transformer required less copper than a two-winding transformer. For the same output and the voltage transformation ratio, an auto transformer requires less copper than a two-winding transformer. So this is a two-winding transformer and this is an auto transformer. So weight of the copper required in a winding is proportional to the current into number of turns. So weight of the transformer, for the winding transformer, the weight of the copper required is proportional to I1N1 plus I2N2. I1N1 plus I2N2. For primary, it is I1N1. For secondary, it is I2N2. So total is I1N1 plus I2N2. So auto transformer, weight of the copper required for section 1, 2, for the auto transformer is, for section 1 and 2, it is I1 into N1 minus N2. And section 2, 3, it is I2 minus I1 into N2. So for 1, 2, it is I1 into N1 minus N2. For 2, 3, it is I2 minus I1 into N2. So the total weight of the copper that is required is the total summation of that two part. So weight of the copper in auto transformer divided by weight of the copper in a ordinary transformer. We just putting those values, and after calculating those values, we are getting an equation called 1 minus 2 N2 I1 divided by N1 I1 plus N2 I1. So you all know N2 I2 equal to N1 I1. After putting those values in this equation, we will get 1 minus N2 by N1, that is 1 minus K. So weight of the copper in auto transformer is 1 minus K into weight of the copper in ordinary transformer. So WA stands for auto transformer equal to 1 minus K into W0, that is the ordinary transformer. So the saving in copper is W0 minus WA, that is K into W0. So saving in copper, that is K into weight of the copper in ordinary transformer. In this way, we can find the weight of the copper required, or the saving in the copper in an auto transformer is the K times of weight of the copper in an ordinary transformer. So types of auto transformer. So the step up auto transformer is generally, from that particular figure, it is clear that when in case of the secondary winding is greater than, so this is the entire portion is act as a secondary and this portion is act as a primary. So that if the secondary winding is more than the primary winding, that is N is greater than NP, it is called a step up transformer, auto transformer. So it is clearly seen in this particular figure. So a step up transformer is a transformer which converts low alternating voltage to high alternating voltage. It is a clear diagram where the entire winding is used as a secondary and a portion of that winding which is common and it is used as a primary. So it is where the secondary winding is more compared to the primary winding. So it is act as a step up transformer or auto transformer. And step down it is clearly seen that total portion of the winding is act as a primary side and a part of the portion is act as a secondary side. So it is known as step down auto transformer, in which the NP, that is the number of turns in the primary side, it is clearly seen it is greater than the number of turns in the secondary side, NS. So this is known as a step down transformer. A step down transformer is a transformer which converts high alternating voltage to a low alternating voltage. So it is stepping down because entire winding is act as a primary and the portion of the winding is act as a secondary. It is clearly seen in this figure. So it is a step down, and it is a step down auto transformer. So conversion of two winding transformer into a auto transformer. How to convert a two winding transformer into auto transformers and auto transformer? So one is called the additive polarity, that is step up, and one is called the subtractive polarity, that is step down. So the additive polarity is clearly seen in this figure. So in this case, the common point A, the common point, that is the A, which is common to input and output, can be taken as the top of auto transformer. This is the general figure, that is common point A is taken at the top of the auto transformer for both input and the output. So thus the input of the auto transformer is V1 and the output became V1 plus V2, the summation of the two due to the additive nature. It is generally used in case of the step up of the purpose of the auto transformer. So in this case, the common current that is flows towards the common terminal. So the total output power is V1 plus V2. It is additive in nature where the input is V1. So subtractive polarity, it is clearly seen in this figure that they are connected in series opposition as shown in the figure. It is called the subtractive polarity. It is clearly seen. So a common point A, which is to the a common point A, which is common to input and output, can be taken as the top of the auto transformer as shown in the figure. So the output will be become when the V1 is the input and the output is become V1 minus V2 due to the subtractive nature. So this type of transformer are generally used in case of the step down purpose. So in this case, the common current that is flows from common terminal. So the input is V and the output is clearly seen there, the subtractive in nature. So the input is V1 and output is V1 minus V2. So what are the advantages of an auto transformer? An auto transformer requires less copper than a two-winding transformer of similar rating. We have already seen that. An auto transformer operates at high frequency than a two-winding transformer of similar rating. An auto transformer has better voltage regulation than a two-winding transformer of same rating. An auto transformer has a smaller size than a two-winding transformer of the same rating. An auto transformer requires smaller exciting current than a two-winding transformer of same rating. So the disadvantages are there is a direct connection between the primary and the secondary. Therefore, the output is no longer DC, isolated from the input. An auto transformer is not safe for stepping down a high voltage to a low voltage. If an open circuit develops in the common portion of the winding, the full primary voltage will appear across the load. In such a case, anyone that is coming in contact with the secondary is subjected to high voltage. It is clear. This could be dangerous to both the person and the equipment. For this reason, auto transformers are prohibited for general use. The short circuit current is much larger than for the two-winding transformer of the same rating. So that a short circuited secondary causes part of the primary also to be short circuited. This reduces the effective resistance and reactance. So the applications, auto transformer are used to compensate for voltage drop in transmission and distribution lines. When used for purpose, they are known as booster transformers. Autotransformers are used for reducing the voltage supplied to a AC motors during the starting period. Autotransformers are used for continuously variable supply. On long rural power distribution lines, special autotransformer with automatic tap changing equipment are inserted as voltage regulators so that the customers at the far end of the line receive the same average voltage as those closer to the source. The variable ratio of the autotransformer compensated for the voltage drop along the line. In control equipment for single phase and three phase electrical locomotives, autotransformers are used. So the limitation is that because it requires both fewer windings and a smaller core, an autotransformer for power application is typically light and less costly than a two-winding transformer. Up to a voltage ratio of about 3:1, beyond the range, a two-winding transformer is usually more economical. Like multiple winding transformers, autotransformers operate on time-varying magnetic fields and so will not function with DC. A failure of the insulation of the windings of an autotransformer can result in full input voltage applied to the output. Also, a break in the part of the winding that is used as both primary and secondary will result in the transformer acting as an inductor in series with the load. The break in the part of the winding that is used for both primary and secondary will cause the transformer to act as an inductor in series with the load. So from that above study, we can conclude that the autotransformer have less amount of copper loss required, high efficiency, possible to get smooth and continuous variation of voltage, continuous variation voltage. So one of the question that we will take that transformer must not be connected to a direct source. If the primary winding of a transformer is connected to a DC supply means the flux produced will not vary but remain constant in magnitude and therefore no EMF will be induced in the secondary winding except at the moment of switching on. Thus, the transformer cannot be employed for raising or lowering the DC voltage. Also, there will be no back-induced EMF in the primary winding, and therefore a heavy current will be drawn from the supply mains, which may result in burning out of the winding. So, this is a main caution that is related with the a transformer when it is connected to a direct DC source. So it is a caution that we can connect a transformer to a DC source. So another part is the three-phase transformer. So we will do the three-phase transformer, the introduction, advantage, principle, and the working of a three-phase transformer. So the generation of an electrical power is usually three-phase and at higher voltage like 13.2 kilovolt, 22 kilovolt, or some what and some higher range. Similarly, transmission of an electric power is also at very high voltages like 110 kilovolt, 132 kilovolt, 400 kilovolt. To step up the generated voltages for transmission purpose, it is necessary to have a three-phase transformers. So what are the advantages of using a three-phase transformer? It is less space, weight is less, cost is less, transport, it can easily be transported, core will be smaller inside, and there is a less amount of space is required for that, and also the weight getting less, more efficient. Structured switchgear and installation of a single three-phase unit is very simple. So in this particular, those are the basic advantages of a three-phase transformer. That is, less space is required, weight is less, cost is less. It can easily be transported. Core will be smaller in size, more efficient. Structure, switchgear, and installation of a single three-phase transformer unit is very simple. So this is the principle of operation of a three-phase transformer. There is a supply voltage, three-phase supply voltage, UR, US, and UT, and corresponding flux is there, phi R, phi T, and phi S. And at that particular limb, the summation of the all flux, that is phi R, phi S plus phi T, equal to 0. So the three cores are arranged at 120 degrees from each other. So the three cores that are 120 degrees apart from each other. Only primary windings are shown on the cores for simplicity. We have seen the primary windings of the cores. The primaries are connected to the three-phase supply. So the three fluxes is also 0 at any instant. So it is the primary windings that is connected in the supplies, which in turn produce a flux, and at any instant the summation of all the three fluxes are 0, that we have seen, phi R plus phi S plus phi T equal to 0. So it is clear that the central leg of that particular transformer doesn't carry any flux. So if the central leg is removed, any two legs provide the return path for the current, and hence the flux in the third leg. It is clear that central leg of that particular transformer doesn't carry any current. If I remove the central leg, the another remaining two legs will be carry the return, will be provide the return path for the current, and hence the flux in the third leg. This is the general principle used for designing a three-phase core type transformer. So the three-phase transformer connections, that is the primary and the secondary winding of a three-phase transformer, as three-phase winding can be connected in different ways, such as in star and the delta connection, which is suitable connection in the voltage can be raised or lower depending upon the star and the delta connection. So some of the commonly used three-phase transformer connection will be discussed in this session. So one is called the star-star connection, another is called the delta-delta connection, another is called star-delta connection, and another is called delta-star connection. So there are three single-phase transformer are connected in such a way in order to form a three-phase transformer. So let us take the primary and the secondary configuration. One is called the delta-delta, the mesh connection. Delta-delta, this is the symbol of delta mesh connection. Delta star or Y connection, it is clearly seen, it is like Y, so it is called the delta star connection. Star delta connection, star-star connection, interconnected star and the delta connection, interconnected star and the star connection. This is the general primary and the secondary configuration of a different type of connection of transformers. So this is the general star connection, where A, B, C are the three lines and they are connected with star with a common neutral N. This is called the general representation of a star connection. And the supplies are provided at A, B, and the C terminals. And this is the general delta connection. It is clear the supplies are provided ABC connection, and in the star connection, the advantage is that we are getting a common neutral. We are getting a neutral in the star connection. This is one of the important factor of the star connection. This is the general representation of delta and star connection. Star delta connection. So the three-phase transformer connection can be connected as star-star, delta-delta, star-delta, delta-star. So this is a voltage and the current. In case of the three-phase connection, the star connection, that is the phase voltage is line voltage by √3. Line voltage is the root 3 times of the phase voltage. Phase current is equal to line current, and line current is equal to phase current. In case of the delta connection, the phase voltage and line voltage are same. Line voltage and the phase voltage are same. Phase current, it is the phase current, that is the line current by root 3, and line current is the root 3 type of the phase current. So we are dealing with the star-star connection. This is the general representation for the star-star connection. Means the primary is connected in star and secondary is connected in also in star. The primary is connected in star and the secondary is also connected in star. So the star-star connection is generally useful for small high voltage transformers. Because of the star connection, number of required transfer phase is reduced, as the phase voltage in star connection is 1 by root 3 times of the line voltage only. Thus the amount of insulation required is also reduced. The ratio of line voltage on the primary side of and the secondary side is equal to the transformation ratio of the transformers. Line voltages on the both sides are in phase with each other. This connection can be used only if the connected load is balanced. So this is the general configuration of star-star connection. It is clearly seen that the primary and the secondary having those neutrals and they are connected in star connection. The primary and the secondary both are connected in star connection. So this is the general configuration of the star-star connection. So another is the delta-delta connection. This is the common figure for the delta-delta connection where the primary and the secondary both are connected in delta. So this connection is generally used for large low voltage transformers. Number of required phase per trans is relatively greater than that for the star connection. There is a number of turns required for phase is relatively greater than that for the star connection, star-star connection. The ratio of the line voltage on the primary and the secondary side is equal to the transformation ratio of the transformers. This connection can be used even for unbalanced loading. Another advantage of this type of connection is that even in one transformer is disabled, system can continue to operate in open delta connection but with reduced available capacity. So this is one of the important connection that is called the delta-delta connection. Another important connection that is known as delta-delta connection. It is connected, primary is connected in delta and secondary is connected in delta. So another important connection is known as star delta or Y delta connection. That is the primary is connected in star, it is clearly seen, and the secondary is connected in delta. So the primary that is connected in star, it is clearly seen, and the secondary that is connected in delta. So the primary winding is star connected with grounded neutral that we have already seen, and the secondary winding is delta connected. This connection is mainly used to step down the transformer at the substation end of the transmission line. Ratio of the secondary to primary line voltage is 1 by root over 3 times of the transformation ratio. So, and there is a 30-degree shift between the primary and the secondary line voltage. So this connection is mainly used in stepping down the transformer at the substation end of the transmission line. That's because the ratio of the secondary to primary line voltage is 1 by root over 3 times of the transformation ratio. So this is generally used to step down the transformer at the substation end of the transmission line, and this is clearly seen as that this primary is star connected and the secondary is delta connected. And that is called the delta star or delta Y connected. That is, primary is delta connected and secondary is star connected. It is clearly seen. The primary winding is connected in delta and the secondary winding is connected in star with neutral ground. Thus, it can be used to provide three-phase four-wire system. This is the three-phase and the four-wire system, as the secondary winding is connected in star with neutral ground. This type of connection is mainly used for step-up transformer at beginning of the transmission line. So this type of connection is generally used in case of the step-up purpose at beginning of the transmission line. The ratio of secondary to primary line voltage is root over 3 times of the transformation ratio. There is a 30-degree shift between the primary and the secondary line voltage. So the ratio of the secondary to primary line voltage is root over 3 times of the transmission ratio, and so that is why generally it is used. This is the delta star connection is used for the step up of the transformer at the beginning of the transmission line, and there is a 30-degree phase shift between 30-degree shift between the primary and the secondary line voltages. So we have seen the different. So today we have seen the conception of auto transformer and the working of an auto transformer, and how the auto transformer can be used, and where those auto transformers are used, and along with the conception of three-phase uh, transformer and the different connection of the three-phase transformer is also seen today, and also discussed today that there are different connections of three-phase transformers. Thank you.